Board on. Yes.
Great. I'm going to exit now. All right. Thanks.
Anyway, so basically, we kind of have these stub functions right here. Let's start simple. We're going to try to find the sum of n elements. Well, non-recursively first, and then we'll go into recursion. So how many elements do you guys want to find the sum of? So it'll be from like 0 to n. So I don't know. We could do
20, 25.
cool. Size t, and then we'll print sum. Is this? Oh, right. Is this font size good for everybody? By the way, should it be bigger, smaller?
Yeah, it's
I
good.
can see it.
Okay.
Yeah, perfect.
So for int. Oh well. Hold on. Size t sum is equal to 0 for int. Right. Yep. Size. Yeah, I know. It's Visual Studio Code takes a while to update. Yeah. See.
Got it.
I is less than num, I plus plus, and we just we sum up these numbers. Oh right, and we sum up these numbers just like we normally do with any for loop because it's iterative. So sum plus equals n, and then I guess we should return sum instead of 0. So just a normal function. They should work. Let's run it.
I see.
625. Cool. Yeah. Wait. Yeah.
So non-recursively.
Yeah. Okay. Hold on. Yeah. Okay. Sorry. It just. I didn't. I'm not sure if we were supposed to do from 0 to 25 or if we were supposed to do 25 times 25.
Well, it's a sum of n elements non-recursively, so I'm assuming it would be what 0, 1, 2, 3, 4, 5, 6, 7, 0 through 25 added together.
Okay. Oh yeah. Right.
So that's what you did. It looks like. I think.
Yeah. Yeah. So let's create a new variable called new num is equal to n new num, and then we would, I guess, subtract 1 from new num for each iteration of the loop. 1 second. $325. Hold on.
I mean, what?
Actually, let's do a smaller number so that we can.
Yeah, that's what I was thinking.
Well, what number did you get?
325.
Okay, that's the right number.
Oh, okay. Really?
Yeah, I just checked it.
Okay. Wait. Let's just check.
Yeah, we could still change it to
Yeah.
an easier number, but yeah.
My
Yeah.
bad.
Okay. Okay. Wait. Yeah. Everything is good. Okay, so now let's do it recursively. So basically, a recursive function pretty much just calls itself. And in order for that to not iterate forever, you have to add checks and whatnot in order, well, just to stop. Oh, Zoom kind of just bugs out weirdly. Anyways, you want to add checks. So, like, for instance, if n is equal to 0, you want to stop the whole loop so that you don't essentially create a while true statement. So,
Question.
Yeah.
So can you run that program again to see how the other one has changed when you did new num minus?
Oh, I did. It works. It works fine. It's
Oh, because now I get it's supposed to go like, for example, 25 plus 24. It keeps decrementing.
we're using 4 now. So just an easier number. So 4 plus 3 plus 2 plus 1, that's 10.
Got it.
Um,
I guess
Yeah.
theoretically, if you wanted to optimize better, you could start it at 1, but it's whatever. I
Yeah.
don't think it matters too much.
yeah, that's a good point. We can do that. Hold on.
Does that break it? Yeah, just make
Yep.
sure.
9. Oh, right. Okay. Yeah.
It would do.
We should probably start sum is equal to 1, and then it'll work. Oh. Hold on. Oh, fuck. Oh, sorry.
You forgot to change it back.
Right.
No, sum it.
Sum it and then, I think we'll run it, but
Yes, works great.
okay.
Optimizing code one step at a time, right?
hmm
So yeah, I actually haven't done recursive functions too much before, so but basically what I guess we should, well, first thing we know is we need to call some recursive one more time, so n minus 1. I'm entirely sure.
Maybe establish the base case first. That's probably
Yeah.
do like a return 0 if n equals to 0, return 0 first.
Yes. Now else, we can probably establish a variable as well. So size t sum, and I guess sum plus equals sum rec, and then n minus 1, maybe. I'm not sure if this will just okay. I'm I'm all for testing, so I'll just return sum and see how this goes. I'm not entirely sure if this will bug out or stop at 3, but I guess we can see.
I think you're going to get, if you plus equals, then I think you're going to get,
Right. Forgot to put it to 0. Now it should be fine. Okay, let's try this out. 0. Okay, that's not great.
Try making sum equal to n, because you're starting from n and then you're going
Yes.
down
well,
one by
you're
one.
still running. You might wanna stop running.
Oh no.
Oh, you're not. Never mind.
Yeah.
I was looking for the done.
Oh yeah, my Visual Studio Code is a weird IDE. I don't know, it frequently bugs out. I just use it for everything else. So hey, it works. I'm actually kind of surprised about that. Why doesn't it stop at why does it still continue to add to sum after 3? It's actually that might be something. Yeah.
T sum is equal to n.
What probably happens is it goes to 3, then it adds 2 to that, then 1, and then it just adds all of that to 4, and as a result,
That's what's happening. You're getting 4 from sum, and then it's probably doing n minus 1, so then it's doing 1, 2, 3.
yeah, and then it's probably adding all of that on top of that, and then 10, I guess.
You could make the if then statement to be n equal to 1, return 1 instead of 0.
Why?
Because there's no point to go to 0. Because you're just adding another 0 after that.
That's a good point. All right, let's see. What happens on, hold on. Can size t be, is the minimum number for size t 0 or 1?
0.
0. Okay, so what happens if somebody just does this? And does 0? Then, you know,
But
I
have
think
you
it's
paid?
better to, I think it's going to go an infinite loop.
yeah, exactly. So
So I
it
think,
wouldn't do an
I think you
infinite
should
loop.
maybe
It would
do less.
Yeah,
it
infinite
just
loop,
wouldn't
You
but
reach.
it
should
will
do
go to.
less
It
than
won't
or
be
equal
actually. It
to 1.
won't be an infinite loop. I think
It won't be an
go to
infinite
like
loop.
a
It'll
big.
just won't
It'll add
run.
up all these size t's. from
I'm
0
just
to.
going to return 0. Is like an outside case. So if we do 0, it doesn't throw an error. That's a surprise.
Well, you could do,
Oh right, and it doesn't equal to 0. Oh, this is important.
what I would do is I would do if n is less than 1, then,
Yeah, that's true.
else if,
That's a good one.
n is less than 1, return 0. And then I would do else, what you have the code underneath it, your else if.
Wouldn't that still okay?
No, I think this is fine, you know?
Well,
And it's less than
yeah, I
equal to
guess it's
1.
the same
Return
code
1.
actually, now that I'm looking at it.
But I guess if you have 0, then you want to return 0. So, yeah.
Wait, let me just check that this works first.
It should.
I
Yeah.
don't think it will work.
Uh,
actually.
yeah, no,
Oh.
it works great.
Oh.
Well, returns, yeah.
So okay. I think this is fine. I feel like if we
Can you copy the code so I can kind of debug this and understand this actually?
you know, I should probably make a replit for all of this instead of VS Code.
Thanks, because
let me.
I actually want to debug this myself to see what's going on so I can kind of study.
Yeah, let me just hold on. Let's see.
It makes sense. I would just take the, method that you have right here from, maybe even like put it in the chat or something and then he can, figure it out.
Huh. The replit, the replit name that I that was randomly generated had malware in it. Oh, that's funny. The name literally said malware.
Nice.
Um.
That was kind of obvious.
Okay, I just copied and pasted it here, and I'm going to share a new screen.
If you want to keep, oh, I guess that doesn't make so much sense. I was gonna say, if you wanted to keep working your VS code, cause it's a compiler that you know works. You could probably do that and then just update the, reply it so that we could see whatever, or so that anybody can
Hold on,
look
let me-
and debug at whatever you're working on. But then you could, you don't have to work in the reply it if you want, you can just make it accessible, but that's up to you.
I mean, I don't think it really matters. VS Code is well, it's about as annoying. So
Okay,
yeah, I posted the replit in chat. Can you guys join? Or are you? Yeah, okay, cool. I see people are joining. That's good. I know sometimes people are just for some reason can't join, and I'm not sure why. So, all right, share. Anyways, I will make this bigger. Okay, so now that we got recursion down, I think we can go on to factorial. So, people here know what factorial is, right? It's you know, it's so 5 factorial is 5 times 4 times 3 times 2 times 1, right?
Mhm.
So we'll just why is it all being highlighted at once? Who's highlighting? Who's
Is that you?
that's
Oh.
not me.
That was actually me. I was
Oh.
trying to copy it to Visual Studio so I could debug this myself.
Makes sense.
Okay, so we can just write a for loop. Well, first of all, let's try to do it on the same kind of style as the last thing. So size t sums equal to 0. Size t new num is equal to 1. Oh, I keep pressing save, but Replit automatically saves for you. So okay, so I guess actually sum should probably start off as 1 because you're multiplying that.
Yeah, the only thing is, I'm realizing about something I told you earlier. If you wanna find the factorial of 0, you're not going to be able to, I
Right.
think.
I think factorial of 0 is actually 1, but hold on. It's either 1 or it's undefined. Yeah,
It's
it's
one.
1. It's 1.
Oh, really? Okay.
So if
It is 1, yeah.
n is equal to
Huh.
0, return 1 else. Oh no, it doesn't need to be an else here. It'll just return 1. Anyways, oh, actually, it automatically does this because sum is equal to 1. So, and we started off as 1 before, so we'll do that. And yeah, so sum is I forgot. I know it's a really basic C++ thing, but is there a times equal kind of operator? Like whatever.
Yeah, I think
Yes,
so.
there is.
Okay,
You,
so
times equals.
okay. And what did we do before? Okay, so new num new num minus minus, and this should work. So we can do, let's comment this out for now. Size t factorial equals factorial, oh geez. Factorial, okay. So let's just do an easy number, 4, and then cout factorial. And let's just run it. Okay, I might have killed, oh, never mind. I thought, it took
That
so
was
long to
long,
respond,
though.
I thought I killed the 24, and that's accurate. Yeah, 4 factorial is 24. Yes, cool. Great. I'm curious, oh, well, we already know that it works, but let's just try other numbers. So 10. Oh, wow, that's a big number, but that's probably accurate. Hold on.
Oh.
It's accurate. Yeah,
That's weird.
why is that weird?
No, sorry, I looked up mathematically why, the factorial of 0 is 1, but it's interesting, but I won't go into detail here.
I actually saw a video about that, but I completely forgot. I think I know what you're talking about, but I
It's
completely
super
forgot.
simple, but it's basically the factorial of 1 is 1. In order for the factorial of 1 to be 1, because of how the, factorial formula works, you have to do 1 times the, 1 times, 0 factorial. So in order for the factorial of 1 to be 1, you have to have the factorial of 0 to also be 1.
Yeah,
That is
yeah,
all that it breaks down to.
yeah. No, that makes sense. I
'Cause if
actually,
you multiply 1 by 0, well, not only that, if you multiply 1 by 0, if you multiplied any factorial, at the
yeah,
end of
by
it, you'd
0,
eventually reach 0.
every factorial would be 0. Yeah.
Yeah,
Oh, hold on.
makes sense.
Okay, so let's just do this recursively then. Is everybody following along, by the way? I don't want you know.
Yeah.
I d- okay, cool. Anybody have any questions?
Not me.
Okay. So let's just do this recursively then. So we're going to call this function multiple times. We need to check. What should we check for first? What do you think?
Well, if n is equal to 1.
Right.
Um,
But what we have currently will kind of already deals with that. So we can just actually do this without having to check for that. I think we can do size these sums equal to 1 and return sum, and then we would just add to sum. Let's see. I guess sum plus equals no, right, times equals factorial rec. Oh my god, why does it keep doing this? N minus 1. And this should work fine. Let's run it on 4. Does anyone here think that there's going to be a problem with the code?
Yeah, I don't think it's gonna end.
Right, yes, good catch. If so, who said that? Was that Ben that said that we need to check if?
It's Michael.
Okay, Michael. Or no, I know that you're Michael, but who said that we need to check if
The base case.
yes, base case.
That would be me, but
Yeah.
yeah.
Ben, right? Sorry, I can't see who's talking
Peter.
on.
Sorry, I realized that. Yeah.
Yeah. Okay. So yeah, you were right. Need to check if n is equal to 0, return 1. We shouldn't have even we didn't even need the else statement before. We can just keep it like this, and it'll be fine.
That's always true, though. Technically.
Oh, exit
Oh,
status.
you need to set sum equal to n.
Wait, what?
Because you're starting from n and
Right.
then you're going n
Right.
minus 1. Yeah.
Oh, strange. Okay, maybe it's definitely not the else, but I don't know. Just put it here anyways. That's weird. I'm not sure why it's doing this.
Yeah.
Can you go down to your main real quick and I just want to see what you're okay, you're returning 4. That's one
Why,
other thing.
how
Yeah.
did that get there? I didn't.
I
type
think it was just a like logic error. You're just like running through things. It's returns.
I didn't type in 4 though.
think.
I typed in 4 over here and somehow it ended up over here. Well, whatever.
Oh, wait.
you're returning
Return 0. Return 0.
Return 0.
Right. Jesus. I'm
Yeah, you're good.
yeah. Okay. Exit status 4. Oh, that's great.
Maybe try, you're not doing the recursive one.
That's
Yes.
true.
Works great. It was so weird. How did 4 get here? All right.
I think you were just coding through and then you just put things into there because you didn't didn't realize, but you were just on autopilot and you saw a return. Same way that you wrote your factorial in the main.
I don't know. I don't remember
It's fine.
yeah, whatever. Anyways, so works great. Let's try with a bigger number. Let's try 30. It's gonna take a minute to run.
That is the problem with the recursive method, yes.
Yes.
Yeah,
Actually-
I'll check it.
Frankly, yeah. Frankly, I don't see the upside.
Ew.
What?
This might take a while, yeah.
I can just Google 30 factorial.
Yeah, I did the same thing. That's why I said it might take a while.
Okay, I'll do a smaller number then. This is kind of Google. The Google machine broke. Let's see. 15.
We could just do something like 3. That should be easier to do the math for at least.
Yeah, we just did 4 though, so okay, I'll
I-
do
Do
yeah, we should
10.
go higher then.
9 factorial then.
Yeah.
Let's try 9. Oh.
Oh.
There we go. Yeah, works great. But I really don't want to check for 30 because it's giving me way too big numbers. At Google
If you
is.
want, you can check for 14. That one's a,
Okay. Oh, which is okay.
which would be interesting because. Yeah, you got the right answer.
Cool. Yeah, so what keeps all right.
That is a good question if you, I don't think you would ever hit, I mean, you could, I guess. Could you hit the limit of your 64-bit? Or is it a 32-bit integer? I don't know, or size
try
T?
it. No.
I feel like size
Um,
T is 32-bit, but I'm not sure.
Okay,
Let's try really bad. No, okay, let's go to 128. I know it doesn't make a difference. It just yeah, there we go. Hit the limit. Is 127? Does 127 work? Oh, okay.
try
Let's
63.
try 63. Yeah, oh, 64 works, so 63 will work.
Oh.
But let's try 100. Oh wow, okay. 80. Okay, I'm pretty sure 80 is the limit.
Yeah,
It's taking a bit.
oops.
Uh,
Well, that's a run through factorial 80 times, so yeah.
oh, 0. Okay. Okay. 70. Let's try 70. Wow. Okay, that's
Try
surprising. 65.
65.
Yeah.
Yeah,
Okay. What? Okay. Let's 66. Let's do 66. Maybe.
it's like trying to find the limit.
Okay. So 65 is the limit. Okay. So this initial guess of 64 was pretty accurate. 65. I want. Oh, probably because it's size T. And it starts at 1, right? I remember
Starts
somebody
at
just
0, but
starts
yeah.
at 0. Okay. Oh, that makes no sense then.
I honestly don't know why either. I could probably find out in a
It's
couple minutes.
probably unrelated. It just the fact that it's close to 64 makes me think that something is
Coincidental.
related, but it probably isn't. Okay, let's move on to Fibonacci. Is everybody getting this so far?
I think you don't need the else actually for
Yeah, no.
So question,
What's up?
I think you got 0 because it's you're getting the max number, right?
Yes.
That's what we were testing. We were hitting, where would we hit the max number for
Is
our
it 30?
bit number?
Is it the max 32-bit number? I think, or what is it for size T?
We also don't need the else anywhere else here.
Because I looked it up. It's like 65,000 something.
Um.
Oh,
yeah, because
Well-
it's unsigned.
Hold on. Let's see. I just want to run these back just to make sure that they work. Factorial rec. 24, great. And let's do
Sum
some rec, yes. Oh, I can just uncomment this out.
Nice.
Yeah. Okay, let's try with 4 because remember that was 10. Great.
Oh, you know that 5 plus 6 is 11, so 21.
Yeah, true. Okay.
So on to the next one, Fibonacci.
Yeah, I guess. So Fibonacci, it's the sum of the last 2 elements in the sequence, right? So it's 1, 1, 1, 1, 2, 3, 5, 8, 13, 18, or no, 21, sorry. Let me just Google what the Fibonacci sequence is so that we can.
Didn't we do Fibonacci sequence for a,
Yeah. I think
Request.
we did. I remember it. Okay, so this is actually a little bit different because we need to
Recursive.
establish 1 and 1 first. Anybody have any suggestions on what we should do here? On how to start off?
I think you should pass it the number in the sequence that you're at. So if you're
Yes, that's
yeah.
that's n.
Right, even if it's like 0 or 1, then you just return 1 because
Okay.
well, because the
If
0 and 1.
should we start off? Okay, I guess we can start off as on 0, like it's an array. If
Or
n,
1, really doesn't make a difference to me.
if n is equal to 0 or n is equal to 1, return 1.
I would just say if n is less than or equal to 1.
Yeah, that
It
works.
covers your negative values then as well, just in case. That is something that,
I feel like
your
actually,
code could be broken, but the thing is, since you put in your own values, I don't think it matters that much.
I feel like it will be broken anyways because size t can't be negative.
Well, that's why you put in a check for it, but yes.
Well, no, I mean size t. We would already be assigning size t to negative number.
That's a good point. I don't know what happens there.
I think it becomes a positive because it can't be.
So it
negative.
checks for it yourself. That's cool.
Oh, cool.
Mhm.
All right. Okay, so well, we should probably start. Oh, we're doing this iteratively, so we're not going to do it in the same style as our previous recursive functions. So
So this isn't recursive?
no. This is iteratively.
Oh,
The next
good.
function will be recursive.
Okay.
Yeah. So size t sum. Sum is equal to 1, and size t new num is equal to n, and then for we're just gonna run a for loop through everything. So
You might want a array.
I don't think we need an array. No, we don't
Oh.
need an array actually because we're just going to be adding up all the numbers until n.
Yeah, we could use an array, but we don't need to. 'cause,
I wasn't actually that clear with that. I apologize. So because I literally just thought about it about what we should do here. So I'm gonna write this in a comment actually so that people well can see it. Basically, what we're going to do is we're going to add all the add all the number out add all the numbers in the Fibonacci sequence until n. Okay. Until
add
n.
on, or yeah, I'd say add n numbers in this Fibonacci
Oh, right.
sequence. but
Add n numbers in the Fibonacci sequence to get the number at n. Yeah.
Mhm.
Does this look good?
Yeah.
Cool. For int I is equal to 0, I is less than well, I is less than n.
Mhm.
Wait, yeah, I n. Okay, I plus plus. We also, oh no, these are two. So I guess
We should stuff line 57 through 59 inside that loop because
Equal
well,
to.
that's where it goes.
no,
well, not exactly, but that logic, the general logic, for when n is 1 or 0, or when I is 1 or 0, we need to handle that case in that loop.
Oh, it's starting off as 0, or it's
Oh,
starting
yeah.
off as 0. So
Yeah.
no, so but basically, line 57 to
Oh,
59,
right.
what they check for is that the input that you get in the parameter is valid, or sorry, either that it's valid or that it's
Right.
not 1 or 0, so that because we already know what that
Mhm.
returns, or what that's supposed to be in the Fibonacci sequence.
Mhm.
In
Okay.
here, though, it's going to start off as actually we should probably start it off as 2, because we're already covering 1 and 0.
Well, yeah, up to you.
And then sum is equal to 2, I guess.
Um, personally, I'd handle like the starting off a sequence inside the loop, but I mean, you'll have to figure out all the same problems either way. So
But
It's just
why would you start off? Why
just so I have a, I don't know. That's
you,
just the way I.
you mean 57 to 59?
Yeah, it's just like preference. I'd want to make sure the logic is going in the right sequence order of events, but
I feel like that's definitely
Wait, hold
inefficient though,
on,
because if you're
hold on.
checking, oh,
yeah,
I'm
it's
looking at
efficient.
the Fibonacci sequence. The first value is 0. A equals 0,
What?
0.
wait, hold on.
Is it
No, it's 1,
neat?
1, 2, 3, 5, 8, 13, 21.
Okay, I'm looking. Yeah, according to this link, the first sequence is 0, and then it's 1, 1.
Oh yeah, I see that
It
if I like Google images.
Yeah,
Okay. I
the
think-
first term in the Fibonacci sequence is 0.
Oh, okay. Okay, so I guess the 0th term in the Fibonacci sequence is 0. That I thought it was
Weird.
1, but
Mhm.
hold on. Yeah, okay, 0.
Kind of makes sense because you start with 0 and then you add, 1 would be 0 plus 1.
Okay, so
F of
yeah,
0 would be equal to F of 0 minus 1 plus F of 0 minus 2. So we're going to assume those two values are 0. So yeah, we'd end up at 0.
yeah. So I just adjusted this so that it
May
accounts for
F
0 instead of 1.
also be 0 then? No, that can't make sense.
Wait, what can't make sense?
Are we running into the same problem?
What's going on?
Hold up, I'm thinking in my head, sorry.
Oh, okay. I guess we'll just work on this for loop then. So it's actually kind of
You'll need
It's
to.
really interesting that if you look at the bottom of this page, there are actually negative sequence values. I mean, I've always seen Fibonacci as like positive value sequences, but they have negative sequence.
Oh, yeah, we actually did do this in a previous quest. Huh. Yeah, I remember that. I forgot which quest that was. That was.
Mhm.
Anyways, I guess
Basically what I would do, and you don't have to do this, I guess, there's many ways to do this Fibonacci sequence. But the way I see the Fibonacci sequence is that your number is equal to the function of n minus 1 and then plus the function of n minus 2. So I would have one value that's equal to the value at 0, and then one value that's equal to the value at 1, starting at 2, and then I have a third value that stores the answer to that.
yeah,
And then
that's
as
what
I
I
go
did in my
through,
quest.
yeah, and then as I go through, I would just change. So for instance, if our names were, okay, if we had some new num and then I guess new num1, let's just say, for instance, I would say sum is equal to, in the for loop, I would say sum is equal to new num plus new num2 or whatever.
Yep.
And then I'd say new num is equal to, or sorry, I'd say new num2 is equal to new num, and then I'd say new num is equal to sum.
Okay. Yeah. No, that's yeah. That
And just
logic.
keep passing through.
That logic works. New num2 is equal to
0.
1. Oh, 0. What? Yeah.
Because it's gonna be, if,
It
for
should-
instance, if we're finding the Fibonacci number for 2, it's going to be 1 plus 0.
1 plus 1.
1
Yeah.
plus 0.
1 plus 0 is
The
not.
Fibonacci number for 2 is 1.
Well,
Right. Wait. Right. So.
oh yeah, that's why.
So because it's the Fibonacci number of 2 is the Fibonacci number for 1 plus the Fibonacci number for 0. So 1 plus 0.
Okay. We can start off with 0. And so sum is equal to, let's see, sum is equal to new num plus new num2.
Alright, see you, Ben.
And what?
Ben said he's stepping out for he has to call out, he has to call Foothill Enrollments. I'm assuming it's one of his jobs.
Cool. We'll see you, and guess I'll see you next class, Ben. Anyways, new num2 and right,
No, it's
so
new num2 is equal to new num.
yes.
Well, now you're just going to go in circles. So I would go new num2 first is equal to new num, and then new num is equal to sum. Yeah.
There we go. All right. And then I guess just return sum.
Yes.
Cool. Okay.
Should work.
Hold on. I'm still on factorial. Let me move to size t. Keeps doing that. Okay, so the fourth number in the Fibonacci sequence, C out.
I think we're going to be wrong because I think we need our for loop to start at 2 as well. Oh wait, 1 and that might work
I
actually.
think so. Mhm.
3. And
Is
the
that what we
fourth.
want?
Well, it's the
Think
fourth
so.
number in the Fibonacci sequence.
Yeah.
And
Yes,
think
that is
that's
what we
right.
want.
isn't 3 the fifth number though? Because
4 is
Three.
equal to 3, 5 is equal to 5. Because 4 is 3 is the
it's
factorial for 3 plus the factorial of 2, which is
Uh.
2 plus 1.
it's 0, 1, 1, 2, 3. 3 is the fifth.
0 is 0 though. So
Zero,
0 is 0.
Right.
zero.
Starts with
Index.
0,
Right.
yeah.
Fair enough.
Sorry. Yeah, it's
Index
getting
three.
confusing.
Mhm.
Okay. Okay, great. We'll just do this recursively then.
Mhm. This is actually easier at the very least to see in recursion. I think Fibonacci sequence is one of those that is used as the example for like when recursion is actually useful.
Right. Oh yeah, I've actually heard that before. Okay, let's just try to do it in, yeah, so size t. One second, let's just go back to what we did before. Yeah, I'll just because I basically I've basically just been looking at our previous
Yeah,
things,
that's a good
and
idea.
I'll just copy and paste this and change it so sum is equal to. Oh wow! Was there another return 0 here? Yeah. Oh my God. Huh. Oh, I'm deleting that.
Well, the good news is we never hit it, but yeah.
Yeah. Yeah, it returned sum before, but that was still that was a yikes moment. So if n greater or less than or equal to 0, return
Say
0.
equal to 1. Oh, yeah.
And so let's see.
It's size t though, it shouldn't ever be less than, or I guess it could be equal to 0.
Yeah.
Yeah, could be good.
Yeah.
It's good. Carry on.
Okay, let's see. Sum is equal to n. Right, so what we want to do is, it's actually kind of
Well, as I've been saying, it's if your Fibonacci number is equal to Fibonacci number minus 1 plus Fibonacci number minus 2, then you're probably going to just do your sum is equal to I mean, hell, you could probably just say return Fibonacci n minus 1 plus Fibonacci n minus 2.
Yeah, I think that's
hold
the
on,
easier way to do it.
hold on. You can't. Size t doesn't go to negative. I think Matthew said that.
Yeah, but
Yeah.
well,
Yeah,
yeah,
it just
it's a little bit excessive, but
it's
it
just
goes
it's
to
just
0.
here, but
Mhm.
yeah, we know.
It'd be equal, but yeah.
Yeah, you should probably just put it equal to be accurate.
Alright.
Yeah.
Maybe.
It's kind of,
It's here in multiple
You
places.
could
so-
probably even write if n is less than or equal to 1.
no, because
Well,
you're using
listen, if
sign,
you
unless we
did-
change it to like int,
If you
can never
said-
get negative.
If you said n is less than or equal to 1, and then you said return n, then it covers both the case for 1 and 0. Because if
Why is
n
this
is equal to
not-
0, then it'll return 0, and
Right.
if n is equal to
Yeah,
1, it'll
yeah,
return
okay.
1.
It's perfect.
Oh, that's smart.
So would we use an array for this recursive one?
Yeah, I
Uh,
bring that up as well, I guess not, because we're just trying to find the value. We don't need to find every Fibonacci number.
Okay, but we need to still keep track of the previous 2 terms so we can get the next term. So
yeah,
We don't,
you guys can-
because the original function does that for us. I think
Right.
we really could just
Yeah,
write
could-
Fibonacci n minus 1 plus Fibonacci n minus 2, and that's our entire answer.
Yeah, yeah.
okay,
I like Peter's solution. So you
So-
write that n less than 1, less than equal to 1, return n. Is that right?
That's what I
Yeah.
said.
Yeah,
I
that's
think
a pretty good
that
solution.
works. That works well.
okay, so.
In your
but-
if statement.
Should not.
Wait,
Yeah,
wait,
change that if statement.
Okay, to less than or
Right.
equal to 1,
Yes,
return what?
n.
N. Yeah, change the 0. Yeah, the 0 to n. Sorry,
1,
to
yeah.
1. Yeah, and then the other one to n.
Yes. Okay, I'll do that elsewhere. 1 second.
Oh, that's your factorial.
Yeah, you don't want to change.
I know, I'm just, okay, whatever. I wanted to change it over there as well, but, anyways, so what, Fib rec-
Fibonacci that, plus, n minus 2 of the same thing.
Yeah,
I think that will give you your answer.
right.
okay, let's try it.
Yeah, I liked how the return statement look. That's more
Oh,
like
we need to have our,
Right, it doesn't have any logic in there, does it? Maybe.
yeah,
I
it
don't know.
makes a lot of sense. You're just adding the previous 2 sequences.
hold on.
Right.
But we don't know what the previous 2 sequences are, we just know that n minus 1, so it's like.
Right. You trust in let recursion take care of
Because
itself.
eventually,
Hold on, because right now it's basically an infinite loop. Oh, 3, okay. Oh, that
It
worked.
works. Wow.
Hold on, let's try for a bigger number.
That should be 8.
Let's try like something like
Spoilers.
20.
20?
All
Nice
right, hold
Fibonacci
on, let's
number.
Go
go
up to
to 20.
14, and I'm not gonna lie, because I have up to 14 in front of
Okay,
me.
Uh,
I'd have to go and find 20.
Oh, 14 should be 377. I'm looking at the
okay.
math is fun.
Yeah, I'm doing. the
Hey,
same
look
one.
at that. Hey,
Oh, it's fast too. Wow.
Yeah.
Oh, because we're
Okay.
not, oh, no, we're still recursing through all of them.
Yeah, there's a lot of recursion going on there, I think.
I guess the only thing though is that all that's happening is checking that if statement and then it's going to return. So it's not that much code, I guess.
Yeah,
It's really fast.
actually,
I'm surprised.
actually,
it's because it
will
already.
be-
I usually find that when there's minor changes to C++, it takes a lot less to compile. I don't know. Maybe there's
Hmm.
some cool optimization thing where it only looks at the differences instead of changing everything. I don't know.
Again, and I think,
Uh,
again, Fibonacci sequence is used as one of those examples for recursion. I think it's one of those few examples where recursion is better to use in your code than a for loop or whatnot.
Okay, we can try looking at the speed.
yeah, because it's easier to see. Yeah.
Seems about the same.
It's hard to benchmark it.
Yeah,
Just put
especially
your
on
Yeah,
the-
they're
best.
about the same.
No, it's hard. Yeah, you
We should
can't-
probably ask Anand when he comes back. Anand
Yeah.
or Anand, yeah.
On.
We should probably
Yeah.
ask Anand when he comes back because
I
Yeah.
think I think the recursive solution is slower.
It would make sense because
Yeah.
of the overhead of calling a function multiple times, but I'm not
No,
entirely.
not just that. I think because the way it builds these past values, every one of those past values is a recursion, like a huge recursion in itself. It looks.
Normally
Whereas-
recursion's slower.
Yeah,
I
but
I
it's
didn't know if that was true
but
for Fibonacci or not.
yeah, but that's not the reason why Fibonacci is slow. I think when you're doing the iterative method, you're just running through a loop, single iteration up to n. Versus if you look at the recursion, it's actually each one of these n minus one minus n minus two is, it's a big chain of recursion by itself.
Mhm.
I don't know if you can see that. Yeah, I think it's easier if you try to like draw this out. Sort of, yeah, by hand. Yeah.
Wait.
What?
So what's your
Here.
point? Is it?
Um,
Are you trying
give,
to?
give me a second. Let me see if I can
Okay.
draw on the screen, and I'll explain to you guys what I mean by this.
You're saying the recursion is less efficient, right?
Yeah,
For sure, for sure. I
recursion
think
is less. Oh, that's just because it's calling a function has overhead.
Well,
It just has
no.
increased overhead.
Not just that it's calling a function as an overhead. It's that in this particular problem, you're making each one of those. Hold on, let me see if I can annotate on the screen. So
Yeah.
like each one of these guys will branch out to some huge tree of recursions.
Mhm.
Yes.
Okay.
Each time it calls
And
itself.
yeah, and so if you think about it, like let's say if you're just doing like recursion of 10, right? It'll start with I think, well, sorry, it'll be it'll start off with like 10 minus 1. So
Yeah.
that'll be 9, and then it'll be do with 8. And then when it calls an 8, it'll do like,
Then you'll
like,
end up with 8,
yeah, you end up with like
7,
6 and
6.
I'm
It'll
sorry,
look like this.
7 and 6. And so yeah, you'll see a huge tree of recursion. But
Yeah.
what makes it easy to see, I think it's like do like a simple problem. So we start with like, let's say a 3, right? So when we go in with a 3, then you're gonna skip through these guys, and then you'll come here. So there'll be 3 minus 2, that'll be a 1. And then I'm sorry, 3 minus 1 will be a 2. And then 3 minus 2 will be a 1. And then so you think of this as a recursion in itself, and it's gonna call fib of 0. I mean, fib of 1, sorry. And this is gonna call fib of 2. And fib of 2 will end up calling fib of 0 and
Yeah.
fib of 1, and then this calls fib of 0, and the other one, I guess we're gonna get
0.
No, I understand.
Yeah.
It actually makes a lot of sense, and I didn't even think about that. A
Yeah.
for loop just iterates through all of that only once, but
once. That's
every
right.
time you
Yeah.
you call Fibonacci or a Fibonacci function, it goes through all of that multiple times, and the amount of times that it calls that is, or the amount of times that it executes that is, it's far greater than just a simple for loop.
Yes.
Right. Yeah.
Well, that is
Yeah.
why recursion is normally slow, but yes.
Yeah, but that's besides the fact that it's probably more costly to go have a function call itself because of
Yeah.
overhead. Yeah, but that's
Uh,
beside the point.
Now the question is,
I don't know what.
personally, for the
Oh.
Fibonacci sequence, the code itself, when I'm looking at it, the recursion makes so much more sense
Yeah,
than the for loop. The for loop is basically taking the original logic and trying to explain it, like
yeah,
explaining how the Fibonacci sequence works. And recursion is just, you just write the function twice because that's how the math works. There's the
Yeah.
solution.
yeah.
Recursion
It's like
definitely looks cleaner. I'm just
the other
I'm
thing
just
in the
not
way
sure
that
about.
I've heard it described to me, I can see how it works in this Fibonacci code, is that in order to write a for loop, you have to understand how all of your loops are going to work and
Mhm.
how the logic all works. Whereas when you use recursion, you don't really have to understand it. You can just, like, as we saw here, like we were trying to sit down and figure out, wait, would the recursion work? And it's like, well, it has to work because that's how the math works. But like trying to sit through and solve through it would be complicated. or we could just trust it and then it just works.
Yeah. I think when you could break recursion down to like a sort of divide and conquer type of deal, then it's really easy to see it. Like in this case, we're dividing a fib of n into two separate recursion of fib at n minus one and fib at n minus two, and you're basically shrinking the problem down one at a time, and it's easy to see, and it's very nice, very elegant this way.
Yeah. I'm not sure. Is the well, I'm just not sure about like what are the practical implication or what are the practical use cases for recursion over over a for loop, because while it does look nicer, it's a lot slower as we
Yeah,
Hey,
and it's actually more dangerous too, because if you didn't write your code right, it'll
yeah,
just
if you
end
didn't
up
have
running
the
forever.
necessary checks,
And
it's,
Again, I
yeah.
think it honestly depends on the simplicity of the problem. If the problem is relatively simple, use a for loop. If the
Yeah.
problem is relatively complex and you have a tendency to not understand the problem, so you're not going to make your for loop accurate, I think a recursion method is the way to go, because you have a lot less of a chance to break something if you can just understand the logic of the recursion than understand the logic of a for loop.
I
I
don't
have a
I don't agree with
question.
that mindset because one second. I don't really agree with that mindset because if you don't understand something and you think you're going to break it, you should understand it first before you code it. Because going with a slower method just because you don't understand something is slow, and it can well, it can slow your code down a
Well,
lot.
the problem you have is, we have things like this, where we have the solution to a Fibonacci sequence already. If we don't have the solution for a problem, and we're trying to use a computer to find the answer to the problem, we might not be able to use a for loop because we don't understand the problem well enough to code an accurate for loop,
Well,
I think.
I mean,
I'm
they
not
also
an
have
expert.
ways to speed up the Fibonacci in terms of recursively by doing dynamic programming, and basically they call it memoization. And instead of trying to compute something that you've already computed before, you just save whatever you computed into like a dictionary, and then you can just look it up.
yeah, no, array or or object.
Yeah.
Yeah.
I'm not gonna lie, Google says the same thing. They say that it's good for working on things that have many possible branches and aren't too complex for an iterative approach. So essentially what I was saying earlier, where it's like if you have a problem that's extremely complex, then going through iteratively is going to be extremely hard, because in order to write that for loop, you have to understand everything that's going to happen through each recursion, quote unquote. Whereas otherwise you could just write a recursion and then just trust that the way that you understand what you want to do is just correct, I guess.
I mean, yeah, I still don't agree with that because I blindly writing code, if you don't understand what the code does, I don't know. I don't think that's a great mindset to have for anything.
Well,
I
it's not
think
that you don't understand what the code does. You understand what your code does, but you don't. But the point is that if you don't understand what what your answer is going to be, in order to use a for loop successfully, my understanding at least is that you need to understand what you should be getting, like what your answer should be.
well, not really. I mean, I could have a for loop that I don't know has the sum of 5 to 677. I don't know what the answer is going to be, but I'll just write it and I'll assume it works, or I'll Google it afterwards. And the same thing for recursion. So I don't know. I think I genuinely think we need to ask Anand about this.
Good
Because,
idea.
yeah.
It's opinion.
Yeah.
No right answer.
The article, I mean, just an article, that I was reading through. I was guessing beforehand, and then I went to go do some research.
You're probably right. I I just think
No,
that,
yes, I agree. Ask Anand because, again, this is just an article. We don't know exactly the,
I mean, an article is
information
way
that's
more
being given.
qualified to talk about these things than I am, but,
oh, I was gonna say Anand is way more qualified to talk about these things than
Oh,
possibly
no,
an article, but
Anand is way more qualified, but an article kind of supersedes me on on the qualification scale. So I'm just saying that personally, it doesn't make sense to use
gotcha.
recursion over a for loop. However, we'll ask Anand, and you're probably right in that assessment. But just just my personal thoughts about that.
Yeah,
I wanna
Peter.
just assume I'm right, but, I agree. I think Anand would have a better understanding of this. I don't want you to feel like you're just probably wrong and you just don't understand it well enough. You could definitely be right. I don't want you to think like, oh, Peter's probably just found an article and now he's probably just more right.
I mean, I'll take it.
I would hope you trust yourself a little bit more, I guess. I don't know. I don't want
see
you to
proof
just accept yeah.
I see proof.
Yeah,
I
some
shrivel up.
problems are easier to solve with recursion because you can see it, like, in this case with Fibonacci. But I've read somewhere that recursions are not allowed in mission critical tasks. Like, for example, NASA would never let you use recursion on a Mars rover.
Yeah.
And the reason is because recursion calls itself, it calls the function itself, and there's something about like
It's just unsafe.
Well, it's unsafe because it could blow up the stack, the stack memory. And so yeah, stack memory is used when you're calling a function. It has to save like the previous address and the current parameters and all that. And if you keep calling yourself, that memory just grows unbounded. And it could potentially grow unbounded because maybe you have a bug in your code. Whereas if you have a loop, there's less likely of that happening when you're writing just a simple iterative loop. Whereas
Oh.
a
I have a question.
recursion, yeah.
What's up, Chad? Oh, sorry.
So I saw you did that 3 recursion for Fibonacci,
Mhm.
but you didn't quite finish it. I was wondering how you get the 2, because I might want to print the screen, take a picture of it to kind of help me study this.
Oh, sure.
Well, it
We did
is-
finish it.
Yeah, it is done.
I saw it, but I meant, how do you get all the way to 2 from here?
Because think about it like this. If we first call Fibonacci recursive and then we run through, so we check if it's 1 or less than 1. If it's not, so if it's 2, then we're going to return n-1 and n-2, or n-1 plus n-2 of our recursion. So then we loop back. Yeah, thanks for annotating what I'm saying. So then we loop back into the same method. We do the same thing. If n is less than or equal to 1, return n. For both of these, we're going to get we're going to hit that if statement, f of 1 and f of 0. So then we're going to return n, which is 1 for f of 1 and 0 for f of 0. So then 2 is going to return 1 plus 0, which is 1, which is the correct answer for the Fibonacci for 2. That works for every single iteration or every single type of Fibonacci as well.
Makes
3, 4,
perfect
5.
sense now. Thanks.
Yeah.
Thanks for explaining this to me. It just, sometimes when there's a lot of numbers, it gets so complex.
Recursion is weird. It's really weird to think about because it's like, how does this work? And it's like you have to.
Yeah.
It runs
Recursion was
through
always
every
my
single time. It's weird.
Yeah, recursion is always one of my weak spots with computer science,
Unless somebody is a savant or just intuitively attuned, I guess, to how code works and how recursion works, I think we can all agree that recursion is not
I think to a lot of computer scientists, it
nice.
feels weird and hard to understand, right?
Yeah, in a way, it's a bit very alien to the way our own brains function, but recursion especially does not, like when you have to really think about recursion in order to understand what exactly is going on.
Got it.
I don't feel bad if recursion is your weak point. I think it's most people's.
Yeah. So, but thanks for explaining it with a simple number.
Hey, Nate.
Yeah. Hi.
Would you be able to refactor some of the other recursions to be kind of like the style we did in line 77?
Sure.
That's a good point. That's a very good point.
So if we were to do the factorial one like this,
So return just
yeah, I guess sometimes that.
yes.
Yeah.
N times.
Mm-hmm.
And well, let's just make sure. Actually, no. Let's apply it to both of them first, and then we'll check that it works.
Mhm.
N plus equals sum
Yeah.
rec n minus 1.
Not plus equal,
Plus,
just plus.
Just plus. Yeah.
Right. Right. Okay, so let's try.
There's something about effect.
It's taking a bit.
24.
24. Okay, cool. Let's try 5.
Oh.
Yeah. Didn't want to do 54.
That factorial takes a long time.
Yeah, I'm not sure why.
I can see
120.
why.
Alright.
Out of the recursions that we have, I think factorial is one of the worst ones for the computer.
I think, can you run the dot time thing again? I mean, the
That's
time,
Okay, let's
see how
go
long
back
it takes
to.
to execute that.
Oh,
If that's just a
Uh,
compiler or something.
Sure.
It's a Linux command. I think he means the time on the shell. I mean,
You know, that execution
Yep.
time, right?
oh,
So I guess
it's-
yeah. Cool.
it doesn't really tell us anything.
Yeah, I
meaningful.
think this thing's kind of broken.
There's probably just a big lag between. I don't know. Maybe just inside of Replit itself.
Maybe it has to compile. server
Oh,
side.
right, time, this might work. Time dot slash the thing itself, maybe?
We
No,
are
not C++.
timing it. It's just too. It's
Not
too
not
fast.
CPP.
Okay.
I don't think because it's not running the CPP file itself. It's running the binary file that it generates.
Okay.
And also I think that the lag just comes from Replit being slow and
Maybe, yeah.
latency between servers.
Yeah, I think
it
I
is
tried it
true.
on Visual C++. Was blindingly fast
Well,
when you
it's
execute it, you know?
0.003 seconds here as well, so it's fast. It's just Replit being slow. So yeah.
Yeah, it's server lag, not console lag.
Is there any other concepts that we're supposed to cover
I
today?
don't think so actually. So
Oh,
I am.
well,
I
Blast
think I
next?
remember my teacher talking about, you know, since code is usually super fast, right? It's best not to like, it's best to kind of use a profiler, right? See what's slowing it down, right?
I don't know what that is.
Well,
but
I don't think we covered this in class, but yeah, there are definitely ways you can properly benchmark
Actually,
a
we
program.
did cover it. We did.
Okay.
When was this?
It was a while back. You
Was
know?
this week 1?
Yeah, I think so.
Yeah, I feel like that was. I don't think that was that
Well,
official
not
C++
properly covered.
material or.
No, it's just a word of advice
Oh.
sort of thing.
You know, word of advice for any kind of code, right?
Mm.
See what's slowing it down, right?
All right. If you want, I guess we could find more things to recurse.
Yeah, sure. Give me some suggestions.
Well, all right. Could we do this in the right amount of time is all.
We have 30 minutes. Well, 20 minutes actually.
Yeah, 20 minutes. I guess it would be an, oh, honestly, I don't want to touch this. It's it's a bunch of future code. Basically, one of the best methods for recursion is navigating a tree or a map of some sort.
Mhm.
But I don't know if I was thinking maybe simulating a map with an array, and then I was like, that's a lot.
That does sound like a lot. I don't think we've even covered
I
have we covered
guess-
mapping in CS2A?
No,
Okay. Nah, then definitely not.
yeah.
How about this? I mean, I think like a couple weeks ago we did like bubble sort with Anand. Well, he kind of showed us. We could try to do bubble sort. That's pretty easy. And it's very easy to recurse.
All right.
Okay. I need
Yeah.
give me a rundown though about
Okay.
bubble sort.
Yeah. So bubble sort. Let me see here. I'm trying to annotate it. Bubble sort works kind of like this. Let's say you have a sequence of numbers.
Mhm.
I don't know, 1, -1, 5, 0, 9, or something like that, right? And the way you're supposed to bubble sort is first it goes in iteration. So the first pass, you want to take this value and compare and try to, well, sorry.
I see. And compare it with the next value and then the value after
Yeah.
that. Okay. Yep.
Yeah, you
cool.
compare this and then you go, okay, 1 is here. Then you compare these and then you pick 5 and then you compare, I'm sorry, 5 and 0. And then you bubble up the highest value, basically, the biggest value to the right-hand side. And that's one pass. And then after that, once you're done with, let's say, we bubbled 9 up there, then whatever you have left here, whatever sequence you have end up like right here, you ignore 9 and you just do this part, you do bubble sort on that, or one pass on that. And so it's kind of like a divide and conquer problem. So that makes recursion a little easier to see.
Okay. Size T.
But you would have to create a like a sequence. Let's see.
Oh, right.
how do
So
you do that?
arrays over here. I completely blanked on where
Yeah.
array should be. Okay.
Oh, then we gotta pass the size. Should we do vector? Might be easier to see vector, or is it?
Oh, right. Fair enough.
boy. Yeah, because I'm thinking of this in Python. We did that in Python class before. It was easy to do it, but maybe not in C++.
Yeah.
No, it makes sense how you would do it. I think I see it. It's just,
We would need to include vector. So.
Okay,
include.
let me think
yeah.
here.
How do we do it recursively? Like, where does that play into this thing, this exercise?
What do you mean?
How does recursion play into this bubble sort algorithm that we're coding?
Well, instead of going through a for loop, we would just we would just recursively try to sort it.
So
Yeah.
we would.
You probably want to write the
Look at-
iterative first.
Yeah.
No.
Well, no, we don't have to write iterative. What we can do is we can just say, we want to check array. Yeah, we want to check, if we have a,
Okay. Yeah, I think you
think I
probably
see.
want to. You don't want to do vector because I think vector is really complicated to do, like chop up a vector. So let's just do like a straight array. I think it might be easier.
Okay.
And,
I guess
and
we
make
can
sure
do
it's and then passing the size. Yeah, passing the size of the array. Yeah.
Oh, I'll just do size. And okay.
And I think that's it. Yeah. And
Why
I don't know
is
if you
it-
need. I don't know if you need to return anything.
When we return the sorted list,
we would
Yeah,
need
I
to
guess.
return the array.
yeah,
No, you don't.
Kinda
You
right.
don't need to. If you edit in place, I think it's just
alright,
pointers.
reference, pass by reference.
Okay, we can pass
Yeah, I
it by
think we're
reference.
all pointers.
Void and then
Mhm.
size T and right. Yeah. And. Or no, and size
Um,
T or size T and. No. Wait, what?
No, size C and.
Yeah.
Yes,
Okay.
I see.
What?
Oh, and something
trying to
about it.
think.
I think it's
Hold on.
dirt.
What? Yeah, no, it should be size T.
You know, I
and.
think you're supposed to,
Like that.
What?
Um,
I'm not entirely sure why this is.
Yeah, I don't think you need to pass in a reference, just pass in a pointer, because we're modifying the memory in place anyways. Is that right, Michael? What do you think?
Well, I mean, I don't know if that's like the right way to write it. Let me try. I mean, I personally will work with a vector instead of the
Okay.
traditional array.
Yeah,
Just
Okay.
because I think vectors are easier to work with.
yeah,
And-
safer. Yeah.
Yeah, and I mean, in terms of trying to chop it up, you can just put like a beginning and end.
Oh, okay.
Positions.
And then can you modify? Oh, I see.
Yeah, yeah.
Okay. All right. Good point. All right, let's do a vector then. Michael's right. It's easier. It's safer too.
Cool.
Yeah. Let's do a
Um,
vector and send in. So I guess you would have to send in. Oh, I see. I guess we could still send in the size because so now it makes sense. Okay, yeah, you could send in the size and just because like the basic idea is you have a your first pass you're gonna try to move the biggest to here, right?
Mhm.
Let's say it's biggest, and then the second pass you're gonna chop this vector down to something one size smaller. And then you're going to send it down to the other
That.
recursion. And that guy is going to send in, let's say this is B0, B1, and it's going to push the biggest value that you can see in that vector into that area. And then you're going to do it again on a smaller array and then send it down to the next level. I think that's how it works.
I see.
So do you actually like iterate through the vector first to find the biggest number and then push it all the way to the
last position? That's right. And then you take a slice of that vector to be one size smaller. So we could pass another number in. Even though vector, you don't really need to pass a size, but we pass a size that we want to stop at. Okay, so you would say maybe the end or something like that.
Yeah.
And that way and by the time we get to one value, then there's no point to process it, and we just return. Yeah.
Yeah, I think
Okay,
it'll be a vector of ints.
Nant has not joined yet.
Unless.
I'm here.
Could we
I'm
just-
watching.
Oh,
Should we
okay.
No,
just
I'm
remove-
just watching. Keep going ahead. So, yeah.
Should we just
if you
remove
want
the
me to
highest
chime
value?
in, yeah. If you want me to chime in at any point, just ask me.
Yeah.
Otherwise,
Hi.
just keep going ahead.
Cool.
We could even remove the highest value and store it. We could return a vector. We could return a vector, be storing the rightmost number into a new vector. And then every time we recurse through, we would just submit a vector and have already removed the highest term from the original vector.
I see.
maybe.
Wait. So if we're trying to declare this vector,
They're both right ways to do it. It's just a matter of which way.
Okay.
I think if you pass the vector in as a reference, I don't think you need to return anything.
Okay.
Yeah,
you can modify the vector in
Gotcha.
place.
I see. You can modify the vector in place and then.
Yeah, and it'll be a vector of
yeah.
int. It'll be a vector of int because we're trying to sort like a list of integer.
I'm not entirely sure why I can't just name it list. What should I?
It's integer type.
INT.
INT.
Right. Oh, it needs to be a type. It's not. That's
Yeah.
you can't call it a variable name.
And then after that, you
yes,
want to do
yes.
like a reference. Yeah.
Yes. There we go.
I'll make it
forgot
a
the order.
reference. Make it a reference.
Oh, right.
Yeah, there you go.
Cool.
Okay. That now you probably want to pass in another parameter. So
It'll be like a size t end.
Yeah, the end. Call that end or size t end. That's right.
Cool.
Yes. So we know when to stop.
Okay. So.
Okay. So the first, I guess the first
wait.
pass. Well, in each pass. We should probably set up the end condition, right? The base case. Right?
Yes. So if
And that'll be
wait, what is end checking for?
you're checking for this.
Okay.
Like if you end up with a list of single item list, then there's no point for you to keep going. So you want to check this value.
So I guess if n equals
what?
to 0, because if n
Yeah.
equals to the first index, which is 0, then you just return.
Return.
Yeah.
Yeah, it's
Yeah,
void.
just
so.
like that.
That's right. Just do nothing. That's right.
So I guess.
We could have another one that says if it's equal to 1, then we just return the first value.
Right, right. Yeah. If it's equal to 1, there's only one value. Well, I guess the
Else, I would do
hold
an
on.
else if.
Hold on. When n, let's double check what n means. Does n mean this position 0, or does it mean like because if n equals
I think it
to
means,
1, are we talking about like position 0 and 1? We're talking about like a list like that.
Yeah,
I think when we say end, and we should clarify this, but I think when we say end, I think we are referring to the size of the array. I think.
Okay.
I mean, I
Yeah,
imagine
which would be
n would be the position instead of, because the size of the array will still be the same when we pass by reference. So every time we do list.size, it's still going to be the same, but n is going to change from, if it's like a 5-element array, it's going to change from 4 to 3 to 2 to 1 to 0.
Okay.
okay.
Why
All
can't-
right. I see what Michael's saying. I mean, if I guess by the language itself, n will be like the position, and then unless we change it to size, then size will make more sense as
What
Yeah,
are we going
I'm not
to
sure why we're
recurse?
not using dot size instead of instead of n.
Well, the
Oh.
reason why is because if you see, if we want to, I mean, this is my understanding at least, if we want to find the, if we want to recurse through, so we keep finding the, highest number in the vector and then pass that into the, rightmost position, then we want to keep, once we find the highest
Size t
value.
is the highest value. I get it.
Yeah,
Sorry,
so then,
n is the
Yeah.
highest value. I'm
yeah, so that's
sorry.
why we want to
I-
go one less, so we don't keep finding the same value over and over again.
yeah,
cool.
because we're sending the same vector all the way down. So
Mhm.
Cool. So
If we use just size,
maybe
dot
instead of
size,
n,
maybe.
we should do dot size, and for n for if n is equal to 0, we should probably do if list dot size is equal to 0.
No,
oh
because
no
this is
no
our point, is that the list dot size is always going to be the same.
yeah,
Okay.
because the
It's
same
just that
vector.
we're making a artificial end for our vector by saying
right.
size t n.
Okay. Okay.
Yeah.
Yeah, because I think the first pass through, when, if it's like a 5-element vector, the first pass through n is going to be position
Return.
4.
Position 0, I guess.
Yeah,
Well,
and then
we can't really return anything because it's void.
Oh.
Yeah.
Yeah.
So-
yeah, that just means like,
If n is equal to 1, then do what?
Hold on. Oh, I see.
yeah, I don't think
So-
you need the second if statement
I
over
agree.
there.
Okay.
I realize how this works. Yeah.
Yeah.
I wonder if the next step, are we going to kind of loop through the
That's right.
until end? Yeah, do a for loop until end and find the largest.
No,
Yeah.
we're
element.
recursively doing it. We're not putting a for loop.
Oh no, we will. Because each step you have to do a loop. Because
Oh.
each step in a bubble store, what
We
you're
are
doing
going
is
to do.
you're bubbling. Let's say this is the biggest value. You're bubbling it up.
I
all
see.
the way
So
to the end.
we're using a for loop and we're using a recursion.
Yeah, that's right.
If you wanted, we
Yeah.
could technically, if you wanted, we could technically do a second method that does the first part recursively, and then we just call that method and then
Yeah.
do the second part recursively. But that's only if you want to do both parts recursively.
I mean,
Right now we could why don't we just write the first part iteratively for now and
Okay.
then
Yeah.
do the second part recursively, and then we can take
Yeah.
a look back at the
That could
iterative
be.
part.
Yeah.
I is less than list dot size, right?
No, not list dot size. You want
End.
to stop at end.
Yep.
Yes. Okay. I plus plus.
less than equal to.
Cool.
Yeah, less than equal to. That's right. Because the index, we want to cover that last one. That's right.
And
Okay.
then I guess.
Then
Wait. Outside
Oh,
of the for
wait.
loop, we have to declare like a max value, and then I think,
Int max, I would say.
and then because we're trying to find the largest element
Yeah.
within the range.
Int max, I'm pretty sure it's already taken for the maximum integer.
Oh,
So.
Oh, wait, hold on.
oh, and
In
also-
this, in the spirit of, bubble sort, right? It's actually not looking for the max and then just putting it at the end. It's actually comparing pairs. Like,
Yes.
you know, 0 and 1 is comparing these guys. And then you, of course, the bigger one, let's say it's, I don't know, 2 and 0, 2 and 1 here. Then 2 is going to be placed here. And then it's going to do the next pair, which is comparing between 1 and 2. So
I
even
get
though you're doing end here, but our I is really this guy here. So we really want to stop at n minus 1. We want to stop I here. The reason is because
Wow.
you're getting this pair here. Otherwise, you're going to get you're going to go
Unless we do,
outside the
unless we
bound.
start I at 1 and then we do I minus 1.
Yeah, yeah,
okay,
you could do I.
It's
Yeah,
either
that's
way.
right. That's
Let-
true. Yeah, yeah.
Let's just do
That's a
I
good
is less
point.
than n. Because either way, it's the same thing, right?
Yeah, yeah. Either way,
Okay.
it's the same thing.
Okay, yeah.
Depending on how you write it.
Max should be an integer, I believe, as well, because we're gonna be storing an int in it.
Okay. I thought we were storing. Oh right. Okay. Yes. Yes. We're storing ints. Int max. And I guess so. In here we're just comparing to.
So max is going, oh wait, no, if.
You don't really need
I
in
guess we have
max
2 if
because
statements.
Yeah,
if you
yeah, you're
if you
right.
swap it, you really need a temp actually because we're trying to swap if we.
Yeah. let's
Yeah,
just write
you're
it down.
right. I misunderstood what bubble sort was. Yeah, you don't need a max out there.
Okay.
I see what we're doing. Gotcha.
So do you just need to like compare the ith element versus I plus 1 element?
That's right.
And then
Yeah, I versus I plus 1.
and then if the first element is larger than the second element, then you just
You
swap
swap 'em.
them.
That's
And then
right.
just keep
yeah.
on going.
List
Yeah.
I, if list I
It's
is
greater
greater
than.
than I plus 1.
That's right.
I guess list I plus 1 is equal to list I and no. Okay. No. Wait.
Yes.
And,
That's
but-
fine. But you
then
need to save
list I
it. You
needs
need to
be-
save list I plus 1. Yeah.
Yeah.
So create a temp.
It is,
Just
yeah.
do
How would I do that?
Just do an int temp.
Oh. Okay.
Oh,
Yeah. That's right.
List I is equal to is equal to temp.
Yep.
And I guess I'll just go for each case. So else if list I is less.
I don't know if
than-
you
Yeah, you don't need the
you don't need
else
it. Yeah.
because
you're done.
if it's
If it's
less
not-
than
Yes.
yeah.
It's not gonna do anything. Yeah.
Um,
So then outside the for loop,
Oh yeah, you don't need the second if statement.
yeah.
really?
Yeah.
But what if
What
if
do we don't need.
Oh right,
to-
yeah, because it already
Yeah.
deals with that. Yep.
Yeah. If it's the other way around, you just don't swap them.
Yeah,
That's
exactly.
what it is. Yeah.
Exactly.
Or if they're equal, then
so-
it doesn't matter.
Okay. And now I guess we do recursion.
So,
Yeah. I think
Okay.
I think
Uh,
then we just call bubble sort, pass in the same list vector,
Yep.
Mhm.
and then it'll be n minus 1.
Yeah.
Yeah.
Okay.
I think that works.
Okay, let's call it.
Create some random.
Yeah, make a random vector.
Oh, we should probably return. No, never mind.
No,
We're-
we don't,
We're-
because, yeah, I
I
keep
forgot.
getting messed up by
Passing by
that too.
reference. Passing by reference. Okay, so let's make a vector, I guess.
Yeah.
What elements should be in the vector?
Just create some random numbers in there.
Let's
Let's manually toss numbers. Don't use random.
Negative
I
because
forgot if
otherwise-
vectors use
yeah.
curly brackets or square brackets.
Square. Just the less than sign. Just start with less than sign. Vector.
Okay, so
Hold on.
Vector int
yes.
Yeah. Int. Yeah.
my vector. Oh yeah, which one? Yeah.
Yeah.
Okay.
And then, curly. You need curly.
Yeah,
braces.
curly
Yeah,
for
cool.
those.
And you actually don't need the equal. The assignment operator. You can just
Right.
use the
yes,
curly.
yes, I forgot.
Oh.
So okay,
wow.
enter.
-2, 5, 7, 3,
0.
3,
0, 2, and then 9. I don't know.
All right.
Oh, wait, we don't wanna, yeah, let's put 2 because, let's just leave it at 2.
Yeah,
Because
leave it
that
at
way we
2.
don't,
Yeah, because we always see 7 bubble up. No, then take the 9 out. Take the 9
Okay.
out.
yeah.
Yeah.
Because we wanna make sure
Yeah.
that we know that the 7's gonna end up over there.
Right.
So we
Okay.
should
Then-
get negative
that-
2, oh, we'll answer it.
Yeah.
And then we should see out list. Yeah. So
Yeah.
list and what would the end be?
This will be
List
size, list size -1, I think.
Okay. List dot size -1.
Why would it
Yeah.
be -1?
Because we're using position, I think, right, Michael? Yeah, so like, if you have 9 items, it'll be up to index 8. Yeah, because
No, we're using end as a, size. Because we're saying
Wait.
I is less than end. That's how we're using end.
Okay,
Wait.
Yeah, this part's always tricky.
no, I
tricky.
thought we're using the index, we're using end as
Well,
index.
as it is
rather than
right
size.
now, the first time we run through, our for loop's going to say size I is equal to 0,
4,
I is less
6.
than end, so it's gonna compare from 0 to 7.
Hold on.
And then find the highest value within, the first 7 values.
Hold on, let's use this one. So this size is what, 2, 4, 6, there's 6 items, right?
Mhm.
And so we're gonna call 5. And that
Yes.
means we'll end up at index 5, but our I is gonna go range from 0 through 4.
Yes,
Is that right? So that makes
Yeah.
sense, because, yeah. So I
Yeah,
think
because
5
it's I, if when I equals to 4, list I,
check
list
4
4
plus
is
4
greater,
and
yeah.
5. Yeah, so
list 5, yeah.
so that's, at least that's how I understood the end parameter.
I'm just making sure that
Oh.
you can print all of them. Yeah.
Yeah.
Yeah, I know this isn't the best way to do it. I'm just, I just want it to be formatted like this.
Yeah.
I know it doesn't matter. Just personal preference. Anyways, okay, let's run it.
Oh, let me erase all this garbage.
Yeah, it looks like it. Wow. It
Oh, yeah.
ran perfectly.
7,
First try.
5, 3, 2.
Oh,
0.
okay. Oh, you have
Yeah,
it
it worked.
reversed. Yeah, cool.
Was it not supposed to be reversed?
Oh, no,
Oh,
I mean,
because
yeah.
it's
Because
just the way
we're
you
looking at
printed
the
it
other
out.
way around.
Yeah,
Oh,
you
okay.
But
printed
it's
it
okay.
out, 5 through 0, not 0 through 5, but it's
But
fine.
it's good. It's good. It looks good.
Oh,
doesn't
right.
sort it.
Yes.
At
yes.
least it's sorted. Yeah.
Cool.
It did sort correctly.
Great.
That's an interesting divide and conquer type of problem.
That's pretty good.
Kind of like. Now, if we can make the loop recursive.
We could also recurse the
Okay.
loop.
Let's do it.
So you're gonna need to make another method for that.
Yep. Compare, and I guess we'll
Oh, I
just
see what's going on here with this.
Mhm.
Then
You're
that thing
going
just.
to, need to pass in the same vector.
Oh no, we just need to get 2 numbers.
Oh,
that's all.
you're right, yeah.
And then, wait.
No, we do need to, we need to pass in the vector. Because we're going
Yeah.
to recurse through and then
Okay.
we're just going to ask it to compare, mhm.
Sorry to interrupt, guys, but it's 9:55.
Ah.
Some of you may be dropping off, but no reason for you to stop. What you can do is, well, I can step out. I don't know when the meeting will end, but I think Nate probably has control over when to end the meeting, right?
Let me see.
We probably won't push past 10.
So,
with this.
Yeah,
you're the
wait.
host now, actually.
Yeah.
Oh.
Okay. Well,
You are
take
the
it as
host.
long as you want. Take it as long as you want. Hopefully you have a recording. If you guys are
I do
okay
have a
with it,
recording.
share the recording with me. You can either post it to YouTube or post it directly to our channel too. It's fine with me, right? Somehow we'll figure it out. But if you want that recording to be out there, just let me know, right?
I'll upload it to Drive and email it to you.
Okay. All right. Well, if you want, you can just upload it to our channel directly. I'll just set you up and then
I don't know the credentials for the channel.
I can set you up. You have a Gmail address. Just send me an email from your Gmail address.
Okay.
And then that'll be easier. Then I won't have to upload it. Okay, great. So it looks like I only caught the last I don't know 15 minutes of this discussion, but it looks like you were a very lively bunch here. But I only see 9 participants, so I'm hoping that the rest of you guys didn't silently drop off.
Ben had to
those
leave.
guys didn't
Ben
silently
left
drop
around 9:20. It's in the chat, and then I think we only started with like 10 or
9
12.
or 10.
I
Yeah,
see,
we
I
only,
see.
yeah, only
off.
had
It
one.
looks like
Can
everybody's
I
stuck on then.
Get going now. That's fine.
Yeah.
Yeah.
Thank you, Chad. Thank you, Nate, for running class today. It's fantastic. I
Thanks.
appreciate it. Right.
I
So,
also,
Yeah.
yeah, this is pretty nice. Thanks.
great.
this
On
was a
Thursday,
great class.
if you can remember to bring this code back Thursday, and if you guys have any questions about this code, I haven't looked at the code, obviously. I'm only looking at like 5, 10 lines or 20 lines that are showing right now. But if you want me to look at this code, just share it with me or bring it back next class. Even next class is fine, right? And we can go over the code. If you want to make some certain changes or turn recursion into iteration or vice versa.
I
you
have
do all
some.
the things,
I
right?
have some
Then
questions.
we'll have time left over.
I
did
do
have
have
one
some questions. I'll ask you. Well, one question.
Yeah,
Oh,
sure.
should I ask you now or next class?
Yeah, ask me now. I don't care. Yeah.
Okay, so my question was, other than like stylistically speaking, what's the advantage of recursion? It seems like it's slower, and there's the function overhead of calling, a function, the same function multiple times.
Yeah,
So,
totally. Yeah,
I'm not
absolutely.
sure.
And it's a fantastic question to ask. Unfortunately, because most of the class is over. I would like to talk more about it than just for 2 minutes. Can you ask this question again next class?
Yes, I will.
Yeah. Okay. Mostly it is for cosmetic purposes, and most of the time recursion is only because the code is more easy to understand and prove things about. Right. Yeah. And then yeah, definitely more overhead. But we'll look at ways in which we can transform automatically without human input. We can look at certain recursive functions that can automatically be turned into iteration by the compiler without you having to look. So we get the best of both worlds.
That's cool. Yeah.
Yeah.
We should definitely look at that.
Yeah. It's called tail recursion. If you want to Google it and look at it later, it's not part of CS2A, by the way, right? So we shouldn't really spend a lot of time on it, but you can look it up. It's just tail recursion, and yeah, and we'll take care of it. Thank you so much, all of you guys. Okay, and Nate especially, right? So it's fantastic.
Thanks, Nate.
Thanks.
I'll see you guys on Thursday.
See you.
Let's finish the compare thing on Thursday, so that way we can catch up.
Yeah.
Sounds good.
I'll leave the meeting. I'm not going to end it. Okay, I'm going to leave the meeting without ending.
Yep, I will stop the recording.
How do I leave the meeting without ending?
I
Take care,
see,
guys.
Chad.
Hold on, let me stop recording.